Imagine a world where the ground shakes with heavy footsteps, and the sky is alive with the beating of ancient wings. Dust rises, swirling around the trunks of giants. A massive shape, taller than any house, casts a moving shadow that stretches across the earth. The question lingers in the air: if these giants ever met, which one would survive? It sounds like a riddle, but the answer is hidden in the layers of time. The truth is, non-avian dinosaurs disappeared about 66 million years ago. The first true ancestors of elephants, small and swamp-dwelling, appeared around 60 million years ago. In reality, elephants and most dinosaurs never crossed paths. But this gap in time hides a story more powerful than any imagined encounter. Extinction is not just a single event. It is a chain reaction of climate shifts, volcanic storms, and new chances for life. In this journey, we will do three things. First, we will step away from fantasy and trace the real timelines. The evidence locked in rocks and fossils will show us why the meeting of elephants and dinosaurs could never have happened. Next, we will meet the true survivors. These are the early mammals that would one day become elephants. We will discover what traits helped them outlast disaster. Finally, we will bring these ancient lessons into our own time. We will explore what extinction teaches us about resilience, conservation, and saving species today. Hold on to that image of dust and trunks. By the end, it will carry a message you can use. Earth's history is written in stone. Every layer of rock is a page in a story that scientists can read. Older layers lie beneath younger ones. Volcanic rocks act as timestamps, marked by radioactive elements. These natural clocks, like uranium, lead, and potassium argon, give us clear answers. Non-avian dinosaurs vanished about 66 million years ago. Across the world, a thin layer rich in iridium, soot, shocked quartz, and glass beads marks that boundary. A massive crater in Chicxulub, Mexico, matches the timing. But the end of the dinosaurs was not a single moment, it was a series of disasters. Massive volcanic eruptions, shifting sea levels, and changing climates weakened life on Earth before the final asteroid strike. After this boundary, the world changed. Small mammals that survived the darkness and hunger began to fill the empty spaces left behind. Within a few million years, the earliest proboscideans appeared. These were modest, adaptable creatures living in swamps that would one day give rise to the elephants we know. This sequence, impact, collapse, and new opportunity, is captured in isotopes, fossil collections, and ancient soils. These records teach us a hard truth. Extinction shapes new chances, but it also limits the future. By understanding how life rebuilt itself after disaster, we learn how today's ecosystems could react to rapid change. Protecting diversity now is our insurance for what comes next. Bones tell stories. Teeth, inner ear spaces, and scars left by muscles are not just details, they are survival instructions. Dinosaur bones reveal how long necks moved, how sharp eyes saw, and how fast bones grew. Early proboscideans show us how teeth changed, how tusks formed, and how strong backs helped them move. By studying tooth enamel, scientists can tell what ancient animals ate and where they traveled. Carbon shows if they ate grass or leaves. Oxygen reveals water stress. When we match these clues with rock layers and dates, a timeline appears. Dinosaurs end around 66 million years ago. Small mammals spread and evolve soon after. But numbers are not enough. Patterns matter. Body size, how quickly animals reproduce, how social they are, and what they eat all form a survival scorecard. Models show that small, flexible animals with fast reproduction survive sudden disasters. Larger social herbivores only thrive if habitats recover. Early proboscideans mixed generalist diets, growing size, and complex social lives. These traits turn disaster into opportunity. This shows us that extinction is about systems, not just single species. It points to our own challenge. Keeping ecosystems complex gives them the best chance to survive the next crisis. The deep bones, the shocked quartz, and the thin seam of iridium are clues that let us read Earth's most dramatic stories. First, there is time itself. Layers of rock and the steady ticking of radioactive clocks mark the fall of the dinosaurs at about 66 million years ago. The earliest ancestors of elephants appear tens of millions of years later. Second, there are the fingerprints of disaster. The iridium layer, tiny glass beads, and deposits from ancient tsunamis all point to the Chicxulub impact and a planet plunged into darkness. Sulfur from volcanoes made the struggle for survival even harder. Third, there are the traits that tip the balance between extinction and survival. Body size, the speed of reproduction, diet, and social habits all combine to give some mammals an edge when disaster strikes. Fourth, we can rebuild lost worlds. Fossils, Pollen grains and isotope clues show how habitats collapsed and then slowly changed, creating new spaces for mammals to thrive. Fifth, behavior and intelligence matter. Evidence of parental care and complex social groups in early proboscideans shows why cooperation became a key to survival after crisis. Sixth, science uses models and experiments to test what could have happened, giving us probabilities instead of certainties. All these pieces turn a dramatic story into careful science. And the final lesson is urgent. Resilience is not luck. It is built into the structure of life. If we want species to survive today's rapid changes, we must protect the complexity of ecosystems. This is the same shield that once helped ancient mammals become elephants. The fossil record and extinction science are not just stories from the past, they are tools for our future. Knowing that a sudden asteroid and massive volcanism collapsed ecosystems 66 million years ago teaches climate scientists how rapid change can reshape food webs. That insight helps us predict how modern biodiversity might respond to extreme warming. Understanding how elephants evolved, with flexible diets, social care, and connected habitats, guides conservation today. Protecting wildlife corridors, preserving mixed habitats, and supporting social groups are all strategies rooted in these ancient lessons. Museums and classrooms help turn deep time into living knowledge. Interactive timelines and immersive experiences help people feel the weight of geological history and support the protection of habitats. Engineers also learn from the past. The elephant trunk inspires soft robotic arms for rescue missions. The story of the asteroid impact drives investment in asteroid detection and defense, turning ancient disaster into modern insurance. On the ground, citizen science projects that track local wildlife and genetic monitoring of elephant populations provide the data needed for smart decisions. Policy must focus on preserving genetic diversity, planning at the landscape scale, and funding rapid conservation responses. These are the same kinds of structural resilience that allowed mammals to rebound after catastrophe. In short, ancient extinctions give us a blueprint: preserve complexity, connect habitats, invest in early detection, use technology and public engagement to turn the lessons of deep time into real protection. Picture a museum hall. On one side, a slab of rock marked by a thin iridium seam. On the other, a family of elephants moving through living landscapes. These two images connect the research of ancient extinctions to the choices we face now. Climate scientists use the record of the KPG boundary to test models of sudden change. Conservationists study the lives of elephants to design better protection for today's wildlife. Engineers and policymakers take lessons from the past to prepare for future threats. Education is a multiplier. Augmented reality timelines and hands-on exhibits inspire the next generation to care for the planet. Even policy borrows from these lessons, focusing on resilience and redundancy so our systems can withstand shocks. These are not just metaphors, they are real experiments and strategies. Ancient bones teach us how to build better climate models, create smarter conservation, design resilient infrastructure, and prepare a public that is ready to act when the next dramatic chapter unfolds. Start with something concrete. Wildlife corridors that connect fragmented habitats allow elephants to follow their ancient paths. Engineers use GPS data and fossil clues to map these routes. Community-led anti-poaching efforts treat locals as protectors and use DNA and dating techniques to track ivory and stop trafficking. Rewilding programs use large herbivores to restore lost functions in ecosystems, but only after careful study. Climate-ready protected areas use paleoclimate data to find safe havens that might survive future warming. Emergency funds, inspired by the urgency of asteroid defense, support rapid action when a species is at risk. Education and citizen science keep the public involved, turning every sighting and every data point into a piece of the bigger puzzle. The lesson from deep time is clear. Use long-view science to guide short-term policy, protect connections, diversity, and social systems. By doing this, we give elephants and all life a better chance at survival. Imagine the fossil record as both a warning and a guide. Real protection begins with 3 priorities: preserve connections across landscapes, protect social systems and animal groups, build science that can respond quickly to threats, create large-scale corridors so elephants and other big animals can move as climates shift, fund conservation that ties local communities to habitat protection, invest in early warning, from asteroid detection to monitoring wildlife with new technology. Education links the past and the future. Museum exhibits and classroom tools turn the story of ancient extinctions into action today. Engineers, ecologists, and communities work together, using lessons from the past to solve problems now. By following these steps, we turn the story of elephants and dinosaurs into a living plan for survival. We are not just saving elephants, we are protecting the web of life that could decide our own future.